All right. This is like the fifth part of our lesson. I'm losing count of how many parts there are to this lesson.
Guys, be quiet.
But this video will focus on doing a full graph of one of those problems that has, different asymptotes. Maybe there'll be a hole in there. I'm not sure. Plus, we need to talk about continuity. Is it removable? Is it non-removable? That type of thing. So that's what this video will be about. All right, problem number 8 here. We're supposed to be doing problem number 8, but problem number 8 is really the same problem as problem number 3 that we already did. So as we look at number 8, I'm going to keep flipping back and forth to problem number 3. Okay, so for example, on problem number 3, we already know that there is a hole at 1 comma negative 8 over 3. All right, can somebody put 8 over 3 in your calculator? Because a decimal would be helpful. 1.36? 2.6? Okay, so this is 1 comma negative 2.6. So that's going to be a hole in the graph. All right? Negative 2.6. Okay. So 1 comma negative 2.6. So go ahead and graph that as a whole. So 1 comma negative 2.6. Remember, you graph a hole as an open circle on the graph. So you can go ahead and do that. We have a horizontal and a vertical asymptote at 4. So we have a horizontal asymptote at 4 and a vertical asymptote at 4. Okay, so I'm putting in these asymptotes. All right, so there I got a vertical and my horizontal asymptote. All right, so let's go ahead and get some points going. This is problem number 3 from the other page. So let's type this into the calculator. Okay, so we graph the asymptotes. Now it's time to plot some extra points. So we're going to the calculator.
Do you have to do something in negative and the positive?
Definitely. All right, I'm just going to go in auto mode for right now. Okay, so let's see. At 0, I'm at negative 1. Okay, so just graph as many points as you can. Okay, so at 0, I'm at negative 1. Okay, and let me get a couple more in that direction. I'm at negative 1 comma 0. Right there. All right, at negative 2, I'm at 2/3. Okay, so that's like there. All right, at negative 3, I'm at 8 over 7. That's 1.14. Okay. Let's see. What about at 3? Scoot down. At 3, whoa, negative 16. That's too far. So at 2, I'm at negative 6. All right, Matt, you're going to be the last one to leave, okay?
Why? I'm checking your calculator.
Class isn't over.
Okay, so this gives us a good view of what's going on with this branch right here. Oh, wow. Just pretend I didn't mess it up so bad.
I can't.
Okay. All right, now we need some points over here past the 4. Okay. But they are mad big. Okay, at 8, I'm at 9. So I got 8 comma 9. So look, this graph is really big, so it's really hard to graph. But it's going to be like this. All right, it's kind of off the graph, but good enough. Okay. So we did the domain back on problem number 3, but let me just re-emphasize it again. Because we have a hole in the graph, the domain is going to be in 3 parts. So we have negative infinity to 1, because that takes us up to the hole. And then this part at the bottom, okay, we have, it goes from 1 to 4. Okay, it goes to the asymptote. So 1 to 4 is my next part. And then we have this part that's up here. And that's from the asymptote 4 to infinity. Okay, any questions? Okay, now the range. The range is the same idea. The range is going to be
Infinity to
right, because we have this break in the graph right here. I have to remember what the y value of this point is, so I can make sure I skip it. All right, this point. Okay, I got to look all the way back here. Yeah, it was 1, negative 2.6. Okay. All right, better yet, I'm going to do the fraction version. So this is 1 comma negative 8 over 3. All right, so this is the point 1 comma negative 8 over 3. So I'm going to have to do my range in 3 pieces. So the range is going to be from negative infinity up to this hole. So it's going to be from negative infinity up to negative 8 over 3. And then it's going to be from negative 8 over 3 up to the asymptote, 4. And then it's going to be the upper part. So it'll be from 4 to positive infinity. All right? Any questions on that range? Okay. Now, increasing and decreasing intervals. Okay? There's no increasing part because it's decreasing everywhere. All right? So, so the decreasing, as far as increasing, we're just going to put none. So for decreasing, it's really going to be the same thing as the domain because it's decreasing over the entire domain. So really, I could just cut and paste this. Okay, so it's decreasing over the entire domain. So the same as the domain is, it's all decreasing. All right. Any questions about the decreasing intervals? What? I just had paused it. Okay. So the end behavior. The end behavior, you should be paying attention to that horizontal asymptote. Okay. So it's going to be like this. As x approaches negative infinity. Okay, meaning as we go towards the left, the function approaches, well, it approaches the asymptote over there. So it approaches 4. Okay, and as x approaches positive infinity, meaning as we go to the right, the function again approaches 4. It approaches the asymptote on both sides. Okay? All right. So we had a discontinuity at x equals 1. All right? It's this hole. Now, is this, when you have a hole like this, is it removable or non-removable?
Non-removable.
False.
What is he talking about?
Yeah, it is removable. If you have a single point that's missing, that's removable. Think of it as easily fixable. So therefore removable. We have another discontinuity at 4. Okay, at x equals 4. Now that's a vertical asymptote. That's non-removable. All right, asymptotes are non-removable. Okay? And we can further classify this as infinite.
How we
Asymptotes are infinite. They go forever.
forever.
Forever, forever. Para siempre, ¿no?
Para siempre, siempre.
Para siempre, siempre. Okay? And I did a bunch of points, but I didn't realize that, you know, you can fill in whatever points you want to fill in from your table.
Yeah.
All right, so that's it for number 8. All right, this video is long enough, so I'm going to go ahead and stop this video here. We still have one more problem to do, problem number 9, and I'm going to let that be its own video. Yeah. All right, I changed my mind. We're going to go ahead and power through and put number 9 in this video. Please understand that number 9 is the same as number 5 from earlier in the review. So we'll use the information from over here. So there are no holes. We have a vertical asymptote at -4. So let's go ahead and draw that. We have vertical asymptote at -4. All right, so there's my vertical asymptote at -4. We don't have a horizontal asymptote, but we have a slant asymptote at y equals x minus 2. Okay, so focus on that. In fact, let me just recopy it over here real quick. We have a slant asymptote at y equals x minus 2. So let's remember how we graph that. So we go to -2 because that's the y-intercept. Okay, and then the slope is like 1 over 1. So that means I'm going to go up 1 over 1 like this. So this is going to be my slant asymptote. The -2 is why we started at -2. Yeah. Be helpful, everybody, not hurtful.
Well, why don't you just, I don't feel like you listen to me.
I know, you got to have patience with my little brother.
You're related?
We're all related. Don't you get that by now?
I'm adopted, so I don't know. I don't know.
We are all brothers and sisters on this planet.
Oh yeah, Mr. Birdemore. Birdemore.
Okay. All right, so there's my slant asymptote. Did I lose anybody yet? No. Okay. I think we had a couple more interesting things. For example, the y-intercept. We have the y-intercept is at 0, comma, -3/4. So I'm going to graph that real quick. So 0, -3/4 would be like right there. So that's my y-intercept. I'll just put a dot there. Okay. What else we got? We have an x-intercept. We have two x-intercepts at 1 and -3. Two x-intercepts. Okay, so 1 and -3. Okay, so let's just find some additional points to make this graph happen. Okay, so let's put this in our calculator. Can you guys remember this and tell me what to type in the calculator?
Yeah, sure.
1 second. So we put the equation in our calculator, and now I'm looking to see what values I want to use. So I have these 3 values looking pretty good already. So a couple values to use, it would be good to see what's going on at -2, for example, and what's happening at -1. So those are a couple good values. So let's check that out. Okay, so -2, let me just skip. Okay, let me just write these down and I'll take that question. So at -2, we are here, and that's -1.5. Okay, and by the way, I might as well graph that. So -2 and -1.5 would be right here. And then at -1, I'm at -4/3. And that's -1.3. So that's right about here. So that gives me a pretty good idea of how to graph this thing already. All right, I often like to see what's happening at the decimals, like negative 3.5, but I'll come back and do that later. Let's see what's happening at negative 5 would be a good one. Wait, what was this? Negative 1.3. All right, let's look at what's happening at negative 5. Okay, at negative 5, I'm at negative 12, so that's really off the graph. Okay, so that's like down here somewhere. Okay. Now, I have a feeling that all these points are going to be off of this graph. All right, notice how I went ahead and stretched out my asymptotes, because I have a feeling that these points are going to be off the grid. So at negative 5, I was at negative 12. What about negative 6? Do I have anything that's going to be on this graph here? Let's see, this at negative 6, I'm at negative 10.5, all right, that's almost graphable. So negative 6 is negative 10.5. Okay, so that's like right here. And what about negative 7? Okay, that's negative 10.7, so it's getting a little lower again. And I'll just do one more. How about negative 8? That's negative 11.25, so it's definitely going back the other way. Okay, so notice all of those points are off the grid. All right, so that was negative, all right, 10.6. I was forgetting to record these. And negative 8 was, what was that? Negative 11.25. All right, so if it says additional points, you should definitely use at least that many points. So even though they're off the grid, just do your best to graph them. And so you can see that it's doing something like this. Okay, 1 second. And then this branch again is doing something like this. Okay, so your graph should look something very much like that. All right, so finishing this up, the domain. The domain is going to, we don't have any holes, so just look at the vertical asymptote at negative 4. Okay, so the domain is going to be from negative infinity to negative 4. Okay, and then union negative 4 to positive infinity. Okay. Now the range is actually we're gonna have to estimate a little bit. Okay. For the range we got to estimate. So the range is going to be from bottom to top. Okay. But from bottom to top, that means from negative infinity to this point right here. This point, there's no guarantee that this is the highest point on this little curve, but it's going to be close. So let's use it. So this was negative 6. This was what, 10.5?
Yeah.
Okay, so let's use that. This was the point negative 6, comma, negative 10.5. Okay, so let's use that as our like relative maximum. So our range then would be negative infinity to negative 10.5. Okay, approximately. And I'll use a square bracket on that.
Why?
Because there's no asymptote here. Okay, it hits negative 10.5, no problem. Okay.
Okay, that makes sense.
All right, and similarly, this point up here is negative 2, comma, I'm doing this point right here. This is the point negative 2, comma, negative 1.5. Okay, so I'm going to use the y value there, the negative 1.5. So I will do negative 1.5 to infinity.
Bracket.
bracket again. I'm talking about this point that's up high. So that's negative 1.5. You can see it on the chart. You can see it on the chart right here, negative 2, negative 1.5. All right, end behavior. This end behavior is going to be normal. Okay, it's going to involve infinity and negative infinity. Okay, so as x approaches negative infinity, meaning as we go to the left, f of x approaches, okay, as we go to the left, this is going down, 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 down. So negative infinity. It's the blue one, brother. Yeah, just sign out. So as x approaches positive infinity, we got to see what happens. So as we go to the right, it's going up, 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 up. So infinity. Yeah, the slant asymptote itself is going up, 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 up. So either way, it's infinity. Okay. Now, the type of discontinuity at negative 4. Well, at negative 4, we have an asymptote. Okay, so that is non-removable. Very good. And it is infinite. Very good. Okay, so let's put both of those words. Let's put non-removable and infinite. Okay? And my goodness, that is the end of this review. All right, this was like the 5th part of the review. So there are several other parts for you to go back and view. Please, if you had to copy off of me at any point while you're doing this, you need to go back and redo the problems by yourself, because I won't be there on the test for you to copy off of. Okay, so make sure you can do the problems on your own. I'll see you on the next video. Good luck, people.